Okay, so it's going to be a over x minus 2 plus a b over x minus 3. There's my little, there we go. If you cover up the x minus 2, you plug 2 into what's left, and the top's negative 2 and the bottom's negative 1. So it ends up being positive 2. And you go this side, and so what, x minus 3. So you cover it up and you plug in 3, which gives you negative 1 on the top, 1 on the bottom, which gives you negative 1. Did you get that?
No, I got -2 over -5.
Yeah, me too.
Now let me check it, because that could be me. So, oh, of course, you plug in 3. You plug in 3. Now, if you plug in 3, do that. 3 take away 4 is -1. 3 take away 2 is 1. I still get 1. Am I doing anything wrong?
On the A term, I got -2 over -5.
Oh, this one. Oh, okay. I thought you were talking about that one. Right, let's check this one then. You plug in 2, so that's -2 over -1, which is still 2. So why am I?
Oh, yeah, I see what I did wrong. Sorry about that.
You should get 2 of these guys, take away 1 of these guys, and then add a C. Are we good?
Yeah, thank
Okay.
you.
Right. Oh, was it just simple arithmetic thing?
Yeah.
Yeah. Although 2 of you did the same thing, so it must have been a pretty common mistake then that happened. I think we're on 10. Oh, excuse me. Oh, yeah. Yes?
Well, I had a question on number 1B.
Yeah, same.
How do you split a partial fraction up? Because you're only meant to do the partial fraction split, right? Okay, so it's 1 over x squared plus x to the 4. Just checking, is that the question you're looking at?
Yes.
Okay, I would hope that you would immediately notice that you can do that, right?
Yeah, I did that.
Now, what you don't know, because we never have reached those guys yet, is that this gets split into 3 pieces. And you get an A, you get a B, and you get a CX plus D. And this has the problem, you know, those x squared ones that we're just starting to look at?
No, we can't see the screen. It disappeared.
Well, I can see it. I don't know why you should be wanting to see it as well. Okay, there we go. Whenever you see a squared term, you have to treat it differently.
Disappeared again.
Yeah, it's because I'm trying to say admit to people, and Zoom just is a pain in the butt. Because you click on one screen and you go and lose another one. Right, I'll stick that window over there for a minute. Right, so here's the guy. You split it like that, and you get an x, which you would expect, or an x squared. What you might not expect is you get both.
Okay.
It actually comes from ax plus b over x squared. But what you do is you split it as an ax over x squared and a b over x squared, and then that cancels down to the a over x plus b over x squared. So it still follows the rule that when you have an x squared, you get an ax plus b on top of it, right? So that would be the partial fraction pattern that you would use on that one.
I'm confused on like the CX plus D.
Why? Or is it, you always, when you do a partial fraction, the top expression should be 1 power less than the bottom. So this is an x squared. So the top expression should have so many x's plus a number. So we call it cx plus d, because neither of those two values are known right now.
Oh, okay.
Now, we will never do it. But if somebody in the future gives you a partial fraction with a 1 plus x cubed on it, which is theoretically possible, you will call it ax squared plus bx plus c. That will never happen to you, at least in this class. But if it ever did, you see the pattern for how you create the top.
Yeah, that makes sense.
Right. Any other questions? Okay. Got a lot to think about. I'm going to have to think about letting some people into the class. I think I'll use that one there as an example as well. Is that everybody likely to be here? Well, good morning, everyone. We are going to be finishing the integration of rational functions today. Depends how quickly we get through that. If we do, we'll then be looking at the next section. And the next section, we'll certainly do that tomorrow. Has homework, but the homework is 0 points, which means you can choose to do it or not. The next section is just, I guess, review would be a good way of describing it. What it does is it gives you a whole mixture of integrations to do, and you have to figure out which method to use, and then you would use it, right? And so it's a kind of good placeholder to put stuff. If you don't do it, you get 0 out of 0. And if you do every single one of them correct, you get 0 out of 0. So it doesn't affect your grade. So you can choose to do some of them, none of them, or all of them, but it is there. So what we are going to begin right now is kind of where we left off last time, just a more difficult version of it. We are going to use the technique of partial fractions to integrate this rational function. Right, when you look at this guy, the first feature that strikes me is, shouldn't the bottom be factored? So,
term on the end, 4 squared.
no, it's 42.
Oh, okay. Sorry.
You'll see it in a minute. I'll write it down a little bit more equal size there. Now, if you pull out an x, you get an x squared plus 7 here, and you've got a dx. So there's not much a common factor. Now, how are we going to split this guy? Well, the x gets you that guy, and the x squared plus 7 gets you that guy. And because this has an x squared term in it, we are not going to be doing the cover-up method. Whenever you see an x squared term, right, a squared term of some kind on the denominator, you have to do what's called the general algebraic method. So I'm going to focus on finding the b, the a, b, and the c. So there's that guy, and I guess I've got enough room for it. x squared minus x plus 42 over x squared plus 7 is equal to that guy. So we take this thing and we say it's equal to that, which is algebraically, and then we take this fella and the other one, and we add them together. And the technique we're going to use is basically you add two fractions which have different denominators, and you add them by changing them to fractions which share the same common denominator. So a over x, right? And the common denominator is going to be x squared plus 7. So this guy's got an x, so I'm going to multiply him by the special version of 1 called x squared plus 7. This one's got an x squared plus 7. I'm going to multiply it by the special version of x. Are you happy about these two special versions of 1 that are going to allow us to add these together? Now that means I can now go a x squared plus 7 plus bx add c times x all over an x squared plus 7, and it is equal to this guy over here. So it's equal to x squared, take away x, plus 42. Okay, for a horrible moment there, I looked at this guy and I said, oh, he factors. And I thought for a horrible moment it was going to be x plus 7, x minus 6, in which case I would have cancelled out the factor and that would have turned into a simple fraction. But the good news, it isn't, so forget that worry. It's cool, everything's good. So we've got this fella on the left. Now we use the properties that if two fractions are equal and their bottoms are equal, then so must their tops be. And we're kind of going through a process very similar to yesterday. So the general algebraic method kind of follows the same pattern that this one does. Right, so we get to that point. Now, when we did it yesterday, didn't we then start playing a kind of weird game? And it basically said, okay, our job is to find A, B, and C. And the way we're going to do it is we're going to use the fact that this expression on the left is the same thing as this one on the right, which means that for any given value of x I plug in here, this side should equal that side. And so we start choosing values of x. And we try and pick them in such a way that we only leave one letter, A, B, or C, alive, right? We get rid of the others. What value of x would be a good choice to get rid of two of these letters and leave only one behind? What number for x could you pick that would leave you just one letter, one variable?
Would it be 0?
Agreed. If you make this 0, won't all of this become 0? So we will choose x equals 0. And when we do that, we get 0 squared, take away 0, add 42. So that's 42. We have a times 0 squared plus 7 plus, isn't bx add c times 0 just 0? So what we now get is that 42 is 7a, and that makes a 6. So by suitable choices of what numbers to choose for x, we can actually find the values for a, b, and c. Right now, we know a. So you go back to this line here, and you use the fact that you now know that a is 6.
how I did
Yes.
it. I was just curious if it was right. Is I took the x squared minus x plus 42 equals a yada yada yada.
Right?
I expanded the entire right side of that, and then
Okay.
I got a plus b x squared plus cx plus 7a, and then I just filled in all the blanks in one go. Is that also acceptable?
Did you still get A equals 6 when you
Yep.
did it?
I got a equals 6, b equals 1 over 6, and c equals -1.
I would have to see what you did. So let me do it on another piece of paper. I'm pretty sure I know what you did. It sounds to me like you have set up a system of equations. But I will hold that thought. Did you get that?
He's sharing his work.
Oh. Well, hold that thought. I'm just going to write it down a little bit bigger so everybody else can see it. Did you get that? Okay. And if you did,
Yeah,
you got,
I did get that.
you get a plus bx squared plus cx plus 7a. And in this particular combination, I think things are going to come out pretty good. So you went and said 42 should be 7a, which gave us the 6 that we've got. Great. And then you went and said cx should be -1. And that's how you got your c. And then you said, I'm assuming, that a plus b is 1. And since a is 6, 6 plus b is 1. So b is -5. Is that roughly your thought process?
Yeah, except I accidentally multiplied a and b, not added. So yeah, it would be -5.
Okay, so you were darn close to a cool little method there. Nothing wrong with that technique at all. In this particular question, it worked out really well. Can I tell you that in general, it will be much uglier than that? The reason why it came out really well was because of this x here. See, if you made this, pretend this term was x plus 1 or x minus 3. If you tried this technique, it would be quite ugly. But it would work, but you'd have to solve some systems of equations. So in this case, really cool method. I like it. But in general, you'll find that it's much more difficult to solve because you end up having to solve like a plus b is 7 and a minus 2c is 10, right? You end up with equations like that, and then you have to use systems of equations, and then you solve the system of the equations and you get your answer. So it will work, but what that technique does is it involves a little bit more work.
Okay,
but
awesome.
It's correct.
Thank you.
It's correct, and go for it. Okay, so we're now at this stage, and I know this method is definitely not efficient, but it is effective. Okay, what value of x can I now pick so that I'm only left with the b or only left with the c? Oh, darn it. I'm in the same trouble. Yeah. I'm keeping this one. There you go, guys. We're using this one. What was going to be my problem? Because of this darn x, which makes this method easy, this x and that x makes my technique very hard because I have to do a system of equations because I can't pick anything. If I pick 0, won't all of this disappear? And if I pick any other number, won't I have a b and a c? So I would end up having to do a system of equations. So I'll leave this one over here for you. and I will show you a system of equations. I'll choose x equals 1. So you get 42 is equal to 8 6s 48. And if you choose 1, you get B add C. And so you get B add C equals -6. And then I choose basically anything I like. So I'm going to choose 2. And 4, take away 2, I get 44. And 2 is 11, so that's 66. And I get 2 lots of 2b plus c. 2 lots of 2b plus c gets me that. If you solve these systems of equations, you will find that c is -1 and that b is -5, and we already know a is 6. So that was a really ugly question, more than I expected. But the choosing technique does work, and as long as you don't have a darn X, it actually works very efficiently. And if it does have a darn X in it, we got a backup plan, although this technique does work. Are you all comfortable about how to solve a system of equations? Math 94, 99. All
Professor,
yes.
isn't it 2C in the you circle like?
Yes, it is. So if you wanted to get from here to here, and I'm saying, are you comfortable with how to solve it? This is one technique for solving a system of equations. You could rearrange this one and get C is equal to that. You can then plug it into here. This question has went roads I did not want it to go. If you add 12 to both sides, you get that. And can you now see where the b equals -5 came from? And then you could work back and get c by -6, take away -5 and get -1. God, that was a long question. And I've almost forgotten what the goal was. The goal was to find the partial fractions, and we now have them. The original integral was this guy. And it is equal to a, which is 6 over x. And then you had a b, which is -5x, and a c, which is -1. And it's going to be over x squared plus 7. But be a little bit careful about these fellas. What I suggest that you do is you take the integral and you deal with it in 3 pieces. This guy is a log. This guy is 1 over √7, the inverse tan of x over √7. If you remember that guy yesterday, anything with x squared plus a number ends up being a version of the inverse tan. How are we going to do the middle 5x x squared plus 7 guy? How are we going to integrate this fella in the middle? What technique? Maybe I should phrase it that way.
It's not a cover up method, is it?
Nope. Five X on the top, X squared plus 7 on the bottom.
Do you use a U
You
substitution?
do. And who's the U sub going to be?
X squared?
5x?
X squared? Any more?
Oh, is
Just
it the
X.
entire denominator? X squared plus
Yes.
7?
And you're going to trust me because you don't have the time. That it'll eventually become that. You can check it out. That is one long question. Are we good? Any questions? Apart from the fact that the ABC part did not come out in a very clean way. It is always going to work if you do the choose X's. But in that particular case, a much more efficient way is to what's called equate the coefficients. Right, if there are no more, I'm going to call that good. And we have some bits and pieces to take over, little bits, little situations we haven't coped with yet. So here is our first situation that we haven't dealt with. And that is, what do you do when the top and bottom pair are the same? Now, you know you cannot use the cover-up method. We mentioned that yesterday. Isn't that one of the rules for the cover-up method not to be used is that the top pair is bigger or equal to the bottom. And the other rule for not using the cover-up method is that there's some kind of square term on the bottom. And so this one fails on the top one. We are going to have to deal with this weird fraction. Any suggestions? This is, we haven't done anything like this, so don't directly think about any of the other techniques that you've seen. Think a fresh look. How do you think you could do this guy?
U sub?
And the T+1 would be your candidate, agreed?
Yes.
Yeah. Totally sensible. Unfortunately, it doesn't work, but good thought. That would very often work in other questions. Totally fresh outlook. You've never done this in any question. In the
Would you
7
split
weeks,
the integral?
say again?
Would you split the integral so that it's equal to 9t minus 8 and then plus 1 over t plus 1?
Oh, interesting thought. No, but I like it.
Minus 17 plus 17.
Where did those numbers come from, David?
Well, since you wouldn't be changing the fraction, you could change it to make it 9t plus 9 minus 17. I saw an example on the homework and looked at it.
Okay. Yes, you can. Now, you might think, what on earth has he just done? Well, if you look at the top, isn't it still 9t take away 8? Agreed? And if you did it that way, you could split it like this. So those of you who were thinking of splitting, it was a good idea, but can you see we're going to split it slightly different way than you might have thought? Now, this guy here is just negative 17, the log of t add 1. But what is this guy? If I pull out a 9, what is this guy? 9 over t plus 1 on the top and a t plus 1 in the bottom. What does that simplify down to?
Just 9.
Just 9. And guess what? We're finished.
Does it have to be negative 17? Can it also be like a combination so that it sums up to negative 8?
Yes, it could be any combination. Unfortunately, you must make it a combination that plays well with t plus 1. So it wouldn't be much help to have a 9t plus 4, because it wouldn't play well with that. And so you're kind of fixed with that being the only reasonable combination. Let's show you another one, just top of my head. How about 3t plus 7 over t plus 2? Right. What you have to figure out is how you're going to split the top to play well with t plus 2, right? Now, you can't do anything about the 3t. What you can do is you can find various ways to split the 7. Give me a combination that plays well with t plus 2.
Would it be t plus 7 minus 5?
Nope, but keep trying. The numbers, I'm going to be putting 2 numbers here. These 2 numbers must be 7, right? I can't change the question to suit myself, but I can choose how to write 7. I could call it 8 take away 1. I could call it 5 add 2. What would be a combination that would work well with t plus 2?
3t plus 6, and then add 1.
Correct. Why are you picking that one?
Because 3t plus 6 is essentially t plus 2 just times 3.
Great. Now see, when you split it, doesn't it split nicely? This becomes a 3, which we know how to do, and this guy just becomes what, a log. Now, did you see that question did not involve partial fractions at all, right? It was a totally fresh, you know, one of a kind kind of puzzle type question. But that's question 11 done. But we get one more of these weird ones. And you have to treat this guy. Right? You have to treat this guy as not an integration by parts, sorry, not a cover-up method or a general algebraic method. I want you to think of it fresh. I want another technique. This one you learned way back in Math 94, 99. No, you didn't. You learned it in week 3-ish of 141. Might have been later. I'll take a volunteer before I tell you.
Is it long division?
It is, you nailed it. Didn't you think to yourself, after you did long division and you sketched rational functions, that that was the end of long division? You'll never do that again. And
I was hoping.
You were hoping, weren't you? Like, oh, I'll never do the quadratic formula again. And years go by, and then 4 questions in a row, you end up needing it, right? Well, here is a long division. You never saw it coming. and you're only going to do it once, and I'm doing it with you. So will you try and put it away in a little box and not lock the door on it, right? Now, it depends who you got, so you're getting my version of long division. You're going to take x minus 7, divide it into this guy, so you cover that guy up so it's not a distraction, and you basically say, what do I need to multiply this by to get x squared? And the answer is you multiply it by x. You then multiply x times the divisor, and you get x squared minus 7, and then you subtract. X, take away x squared, gone. Nothing, take away negative 7, gets you plus 7. In this case, when that term is a smaller power than this, you're finished. So as far as the long division goes, it's x plus a remainder of 7 over x minus 7 dx. And that guy is a half x squared, and that guy is a log. And there's one of the shortest long divisions you've probably ever seen. You cool with that guy? I think that's it. I'm just doing a quick scan. I think, yeah, pretty covered. Some of you may have missed the start of today because someone asked a question about the homework. So I'm just going to repeat that question a second time. And the question was, how do you set up this guy? So it's question 1b. And of course, you would factor it first. And then the 1 over x squared actually generates 2 terms. And the 1 plus x squared, so gets you a cx. Damn it, I don't know where my brain is today. Cx plus d over 1 plus x squared. And if you're wondering how that kind of turns out, you've got a square term. Actually, you've got 2 kinds of square term, this one and this one. This square term originally starts off life like that, and the other square term looks like that. But this one gets split. And this other one doesn't, because you're not like to split fractions with pluses in the bottom. And this simplifies down to the a over x and the b over x squared and the c over it, that guy. Now you want to solve this question, you would essentially do the same technique that we described where you combine the fractions together. This one, you're going to have to solve a system of equations, but you should be able to, by picking x equals 0, at least get one of the variables d as a number. And then you end up with a system of 3 variables, believe it or not, and good luck. Well, we are finished with that section.
I have a question on number 10, the long division one.
Sure.
I tried to follow along with my own question, but WebAssign didn't like it. So
okay, give me your question, we'll do it again.
Yeah.
What did you have?
X squared over x minus 4.
Okay. So you would do x minus 4. You do your x squared. Right, what gets you that? X gets you that, right? X times x gets you that. Multiply them together, you get an x squared. Oh, shooting space. Nobody saw it. And I'm glad you brought that up.
When I
did
double checked
question-
my answer, there was like terms in there I did not recognize.
Right, let me do this guy again, everybody. I guess I was in such a hurry to get to the next section because it's kind of fun that I didn't do this one.
You
You would've
just
did-
also put the long division in a box.
Right, so this is this question. This one will work now. When you see how I screwed up this one. The X is correct. You multiply. You don't get that. What do you get?
You get x squared minus 7x.
Right.
Oh, that's I was.
That's what I did wrong. Now, X squared, take away that guy, gone. Nothing take away this guy gets you 7x. So you are now left with X goes into this guy. And the answer is plus 7. Then you do 7 times this guy. And you get 7x, take away 49. And then you subtract that. And 7x, take away 7x is gone. And nothing, take away that guy, gets you positive 49. Now you can stop. This fella is x plus 7 with a remainder of 49 over x minus 7s. And so the missing term is important. And this changes its value because of that. There, that should have been the right one. Put that guy over there. We'll do this one just as a second shot. X times this guy gets you x squared minus 4x. And then you subtract. X squared, take away x squared, gone. Nothing, take away negative guy gets you 4x. You look at this guy and you look at this guy. What do you need to do to that to get rid of the 4x? You need to multiply it by 4. And you get 4x, take away 16. And then you subtract. 4x, take away 4x, gone. Nothing, take away that guy, plus 16. So we now know that this fraction can be written as x add 4 with a remainder of 16 and 16 of those. This guy is a half x squared. This guy is 4x and that guy is a log. You want to check that one, see if it works.
Yeah, I'm plugging it in now. It does.
Right. Now, you could put anything on the top. Thankfully, it's only x squared, but it couldn't have been x cubed plus 5x squared minus 42x plus 1,000,000. And wouldn't this process take care of most of it? And then you'd be left with a little baby remainder that gives you a lock. I'm glad you caught that, because a lot of people would have screwed that question up because a little x, that's all it takes. Well, we are now officially, because I'm excited to show you these guys, because I'm going to get you to revise lots of different techniques. Now, what kind of techniques have we got? Well, we've got U subs, right? We've got X subs, X like, 3 tan theta, those kind of things. U subs like, X cubed plus X, We have integration by parts. Wouldn't that be things like f of x is x cubed and g of x is e to 2x? Remember those guys? And we have rational functions. But if we're doing rational functions, isn't there basically 3 techniques that you would use in rational functions? At least 3. We have the cover-up method. We have the general. algebraic method. And we have long division. Oh, and how about I have a good memory? What do I mean by that? If somebody says to you, what's this guy? Or let's make it a little bit more interesting, what's that guy? Haven't we just memorized what the answer is? Right. And I think I've covered them all now. Don't we have the power rule? That's quite a toolbox, isn't it? Of things or techniques that we use to find integrals of guys. It's quite an interesting choice of things. So you are going to get me asking questions, getting very old, while you lot don't answer me. So you are now going to be thinking cap on. And if I ever get this darn thing to work, you should be looking at 7.5. And I better take those darn solutions away because that would spoil the party. And you are going to look at questions and you are going to tell me techniques that you would use. What method would you use? I don't need to know the answer, but what method would you use to do question 1A? This is where the rubber meets the road. Because up to this point, you've been spoon-fed the method. Because you did a section where nothing was U-subs. So you didn't need to worry about it being a U-sub. You knew it had to be one, right? And you had a whole section which was integration by parts and so on. Now you're in deep water. What method?
Substitution.
Agreed. What would your U-sub be?
1 plus x squared.
Okay. C.
That's memorized, right? Isn't that one of the sines or tangents or something?
If there was a square root in it, you would be right, but it's not. But you're on the right track if there'd been a square root round the bottom. I'm going to put time limit on these. Come on.
That'd be 8 ln of 1 minus x squared.
Nope, but I know where you're
Oh.
going. If you factor it as 1 minus x, 1 plus x, isn't it a rational function and you'll use the cover-up method? Now, the one above it, what's the technique for a over 1 plus x squared? Somebody already gives the answer to that one indirectly.
Tangent?
Yeah, it's a tangent, isn't it? Inverse tangent. It's just I've got a good memory one. See how much more fun it is when you don't know what the method. It is fun. Stop shaking your head, Ismail. It's fun. And it makes you think it's fun. 2A.
X sub?
No, but keep that thought for another question. I would use X sub for B.
Oh, this is U sub, isn't it? Because if you
It
take
is.
yeah.
Do you see why the A is a U sub, x squared minus 1? But why is B an X sub? Isn't it to do with where the square root is? Right, can you imagine doing that one? Right. I believe that is the secant. So that would be x equals secant theta. What about that one? Ah, that's got you. What about that one?
Isn't a U sub under the square root?
So you'd use what? X squared minus 1, I'm suspecting.
And
Yes.
you divide by another x.
If you did a U sub on that one, I think it could work.
Because you can split the into 1 over x, and that becomes a natural log, right? And then
Oh, if you're doing that, you're doing integration by parts, and no, don't go that route. But I think the U sub could work. I'm thinking it's an X sub just because it's an ugly square root. You know, when I see ugly square roots, I think it's probably an X sub. I try and see if a U sub works first, but if it doesn't, or I think it's going to be hard, then I do an X sub. What about 3A? How would you do A?
Parts?
Correct.
Parts.
Correct. Who's the f of x in 3A?
ln? Okay.
Correct.
Mhm.
Yes, ln of x, correct. What about B?
U sub. Actually, would you even need to?
No, I wouldn't do the U sub. What about B?
Parts again?
Yeah. Who would you
Yeah.
make the f of x?
ln 2x.
Correct. And by the way, so is C. So just to prove that you can get the same method used in 3 questions, don't talk yourself out of it because the first 2 were, integration by parts. I must be doing at least one of them differently. That one just proves the point. What would you do about 2 sine squared x? And I phrased it a slightly different way than I typically do. I said, what would you do with it?
Trig identities?
Yeah, trig identity. Half 1 minus 2x, cosine of 2x. What about 2 sine cubed x?
Would take one of the sines out and then make the other one 1 minus cosine squared.
And then do a u sub, yes?
Yeah.
What would you do in 2 sine 2x?
Shortcut?
Yep. Or u sub of 2x if you don't like the shortcut. What would you do in question 5? For me, this is the fun part of math, where you get questions that could be anything and you have to think about them.
Could
What
you
method?
use the general algebraic method?
No, I wouldn't use it with any trig function. Not
okay.
good.
Then could you use trig values?
Or a trig identity, not this time. I wouldn't think that would work. Something more obvious. Maybe it's so obvious you're just not even registering it.
Did you turn it into?
Like parts.
No, see, you're all going different roads because you've walked by the front door and now you're trying to climb in the top window, right? You're trying to make it hard for yourself.
You could probably just U sub
Do a U sub. And who's the U sub going to be?
sine of x, because we can get rid
Oh.
of cosine. Oh,
Cos
7 minus the sine of x.
oh,
Right,
right.
the whole
so-
bottom,
Yeah.
right? Right, try and walk in the front door, right? Try and find the easy way before you start, making life weird and going places that, I can imagine situations where it would happen. Would you agree this one is an integration by parts?
Mhm.
And f of x will be log y. In fact, when you see a log y floating around, isn't there a fair chance that it's a u sub or an integration by parts, typically? What would question 7 be? We'll make this the last one because I just looked at the time there. So while we're thinking, you can type in your last name. What would you do in question 7?
Is that the not necessarily the cover up method, but the stuff we've just been doing? So splitting apart the denominator.
God, that would work, but you're climbing in the top window again. There's something easier than that. Relatively speaking, none of the methods for that one's going to be easy. It's something that would be less work than the way you said. The way you said would have worked. No problem, it would have eventually worked. But there's a better way.
If you split it into 2x plus 1 squared and
No, don't go
times
there.
2x plus 1.
Don't go there.
Is it a
Thank-
use of
I would. Who would the U sub be?
2x plus 1?
Right, you trust me, there's a little bit math to do, but eventually that would work. Would you all agree that it's not that easy to do when you don't already know the method? So don't get lazy. And I think that group of questions is really good at doing that, of showing you that you have one skill that you probably haven't honed yet, which is what method do I use? You've never really worried about that right now because you never had to. You see how much more fun it is when you don't know. And then, Ismail, I'm going to work on you. Don't you shoot your head anymore, your head's going to fall off, right? Treat it as a challenge, but it is fun. I know it's frustrating sometimes, but I think it's fun. Anyway, bye-bye, everybody. You've already hopefully said your last name, and I will see you tomorrow, where, guess what, Ismail? We get to do more of these.
Is WebAssign correct that 7.5 is extra credit?
No, I don't know if it called it extra credit, because I never called it extra credit. It's just 0 out of 0. That's all I called it.
Okay.
Extra credit.
So is that what they call it when you do that? You're getting nothing for it.
I guess.
You are doing it because you want to get practice at the last skill, which is which integration method. Because we've basically finished integration as in techniques, right? There are no more techniques to learn. But you have to figure out which one's the right one for a particular situation. I got some really cool insights into some of your brains. Some of you like exercise. You like climbing in the top window all the time when the front door was open. Right?
My favorite method is use sub. If it's not use sub, life gets
You're in trouble.
difficult. Yeah.
Well, I mean, use sub's a very powerful technique. It does appear in many questions, doesn't it? There are lots of situations where that's the right technique.
I just
But it's-
continue
it's-
to do use subs all the way until I have to use the letter Z. Maybe it'll work.
Well, you know, good luck if you have that as a strategy. I'm not sure it's going to end well for you. Try to do a use sub on a question that involves integration by parts tends not to end too well. Okay, any questions?
Professor,
Yes.
I have a quick question about the task 2. Since I recheck my answer in Precise through Decimal and other tools, and I know there must be some errors, but I did not find them. So I'm just asking when maybe I can have a report for task 2, so I can see which
I have
one
sent,
is
yeah,
wrong.
I have sent out test 2 reports. So if you've not got yours, what I suggest you do is you send me an email with your email address in it, the one that you want me to do. Will you send it inside the email, right? So write it down exactly the way you want it, and I will send you your report. I have sent out a general report. I don't think you're in China right now.
Yeah, I'm in China right now. So I just saw my
I'm
grade for
wondering
the
if it's
test.
just the email thing that's getting it. Anyway,
Okay.
sorry, you were saying what?
Okay, thank you.
Okay, so you send it to me and I will shoot you your report right back to you.
Okay, thank
Okay.
you.
You're welcome. And the solutions are online, so you can see them when you want to look at, you know, what you did and compare it to what you got as an answer.
I saw it in the canvas.
Yes,
you.
in the canvas. Any other questions, guys, before I kick you out, because I'm going to be going to my next class after this in about 30 seconds.
I do have a
Maggie.
question. Can I see the piece of paper, or can I get a picture of it later with the red writing from number 13?
Red writing for 13 coming up. Red writing for 13.
Or I can come into office.
I-
It's better.
I think it's this
have-
one. Let me do it right now. I don't have a number on it, but it has lots of red writing, so I'm assuming that's one you want. Is it this one here?
Yes.
Okay. So essentially I choose x is 1 and I choose x equals 2, and that allows me to solve a system of equations. And the two equations end up being this one here and this one here. And then if you use the technique that you learned way back in 94,
Your coffee ate the X
what's that?
on the top right. Your coffee ate the X on the end.
Oh, here.
That's what the orange splotch is.
Yeah. For me, it's not coffee right now. To me, it's actually water. I don't drink coffee, but any kind of liquid in this paper, and it doesn't take much, does it? Right. Have you got it?
I'm almost there.
Okay, I'll get ready for my next class, so that is fine. I can do that while you're doing that. Eventually.
When do
Huh?
we talk about the cry method?
When do we talk about the cover-up method? If
The
you
cry
yeah,
method.
The cry method, isn't that like
Okay.
every time we do homework?